Okay, let me just share my screen. And last week we have some brief introduction about the field practice, and it would be good for you to review this the field practice procedure again, as you have already conducted the first lab experiment. Basically, we have some standard procedures for you to conduct the surveying. In the field, you need to have the well plan about all the tasks, and you have to record all the measurements by hand. Even for those record that could be stored in the some of the electrical devices, you still need to record by your hand to to do the cross verification, make sure that there's any potential error there. And you need to do the field computation before you leave the field to make sure that there isn't any major errors in your experiment. And after you return to your office, you need to do more detailed analysis about the data and using the result to set up the actual project for the which can use your surveying result. And we have some in the surveying, we have some specific requirements for usually we have the requirements for the horizontal and the vertical measurements, including the distance and the angles. So which means that we need to identify some accuracies for the measurement and the different directions. And sometimes we have to locate and analyze all the existing control map, photographs, and some of the other data, which will use them as a reference points and use these reference points to develop or conduct your own project. And for the select, you have the various options to choose different equipments to conduct this surveying. And you need to find out the right equipment, and you must be familiar about how to operate the equipments. Also, you also need to know how to analyze the data you collect in the field, and also the way to present your result to the other audience. Make sure that the result is straightforward for the audience to understand. And there will be some concepts that we went through them quickly last time. But if you go back to check this concept again, you will have a better understanding, especially after you complete your first lab experiment. For example, in the first experiment, we are working on taping to measure the distance, the horizontal distance. Taping is the way for you to do to conduct the sorry, let me just disable the timing. The taping is the way for you to measure distance with the tapes. And also you have someone called the flagger, as it usually indicates one person to hold in the flag and identify one as the mark for you to measure the distance. And you have the rod person. This will usually be applied for the leveling measurement and also for the traverse measurement, which will be the experiment you're going to do in the future. So for the rod person, they will hold in the rod for you to measure distance from current location to the person where is standing. And you have the foresight and backside, which is related to the leveling measurement. And then there will be more detailed definition about it. Also, we have the gradient to measure the slope. We have the hub to place the equipment, and the lines is the one you have to measure the horizontal distance, vertical distance, or the slope distance. And the turning point is where you're gonna change your location along the line or the curve that you want to measure. And also you have the benchmark, which will be the reference point for your measurement. And usually for the taping instrument, we have the tape, and we also have the electrical distance measurement equipment, like we can use some radar, or you can use the total station for the distance measurement. And GPS is also another advanced measurement tool. You have the leveling rod. This is the one for you to measure the elevation. between two locations, and usually we have one person to hold this rod. And also we have the theodolite, which is mainly applied to measure the angle, the horizontal and vertical angle. And we have total station, which can help you to get the distance and angles automatically and with very high accuracy. And also we have GPS. This one will rely on the satellites outer space, and you are able to find out the location and also measure the curve or the line easily just within one piece of the device. And usually in the experiment, one of the important parts is about the adjustment of the instrument. You have to make sure that your instrument is leveled appropriately, and you know how to do the make an adjustment efficiently. This is some background information you have to know before you do the experiment. Otherwise, you will spend a lot of time to make sure to set up the instrument, and probably especially for the last experiment, you may not be able to finish all the measurement of all the points in the assigned time. So get familiar about the instruments and know how to adjustment correctly is very important. So to do the adjustment, you should first understand the principle on which the adjustments are based. Especially, for example, for the leveling, you need to make sure that the bubble is located in the center of the indicator. And you have to know how to adjust the screw to make sure that the bubble will move to the center. And you need to know the second thing is that you need to learn the method to do the adjustment. And also you have to appreciate the effect of the one adjustment to another. Sometimes if you do the, let's take example about leveling again. Usually we will have three points for you to do adjustment. You can adjust the 2 points to move the location of the bubble, but that may not make the bubble move to the center. So you need to do another one, the third one, but this will also move the bubble to another direction. And you have to know that how this adjustment from different points will affect the movement of the bubble in the indicator. And the last thing, which is very important, is like we have to know what's the order for you to do adjustment. There will be some standard procedure to do the adjustment, and if you see one kind of issue about the instrument, you should know what you need to do to fix it. And we will have the lab technician and the TA in the field to give you a demo about using those instruments. Basically, in this class, we're going to use two pieces of instruments. One is the transit level, the other one is the total station, and we will show you the demo about how to do it. Here would be the two videos about the transit level and the satellite. Satellite is in the low version of the total station. You can go to check these two videos to see how to use these two instruments. And the instrument in our lab is a little bit different from this one, but they are very similar mode. So you can still get some sense about how to adjust the instruments. And I have already introduced the field notes, and this is very important. In your field notes, you need to not only record the observations from the instrument, but also you need to have some explanatory notes about how the observation is recorded, what kind of potential issue when you read the value from the instrument. And it's better for you to have a sketch about the areas you are doing. And of course, the type of the instrument, the weather conditions, and the name and duties of your team members should also be recorded. And in the field, you need to do the field computation. For example, you have to, if you are trying to measure distance, you need to check whether the distance is correct or not. This is a very rough correction. Like if you measure on the long distance, and usually it's approximately around 50 meters, but you measure at 30 meters, you will quickly know that it's an error. So you need to redo that in the field. After you return to the office, you need to do the office computation. And for that one, you need to do some further correction about the data that you obtained from the field. And there is a way for you to do the correction. And of course, we're going to introduce how to do the correction in the future. And this would be all the information you have to remember to put in your field book. You can go to check all this information and verify the field notes that you collected in the experiment this week. And in the next week, you will have a better idea about what part you are missing, and you should put it there. And what I suggest that you should print out this page and put it, bring that one with you in the field experiment, and make sure that you have all the information in your field book. Okay, so that will be the field practice. We have already completed the first one, and start from next week, you're going to work on leveling and transit. And you need to, for each session, the groups will need to rotate. Some will be assigned to leveling, some will be assigned to the transit. And after that, you will work on the horizontal curve measurement and topography. Okay, so that will be all about the field practice. And do you have any questions so far? You can raise your hand if you have any question, or you can, I'll just go open my other computer to see whether you leave any questions in the meeting chat. Okay, any questions so far? Okay, if we don't have any question, I will go to note 5, which will be the first basic measurement, and it's related to the lab you conducted this week. So in note 5, we're going to introduce the distance measurement. We are going to show you how to measure the distance, which will mainly about the horizontal distance or the distance along the surface of the ground. Just a moment. Let me remove the try to remove using time. Okay. So as we usually there will be multiple ways for you to conduct the distance measurement. Pacing would be the one easiest way. You can just use the pace to measure the distance, count how many paces you walk from the origin to the destination. In the lab experiment, you also conduct some experiment with the distance measurement with pacing. So everyone will have different values for each step. So the number of the paces for one distance for one line will be different if it is counted by a different person. And the second one is called the odometer reading, which is also the one that you are conducted in the experiment. So you're gonna using the a wheel to measure the distance from one location to another one. And of course, you have the tachyometry. This is a stadium method to measure distance. We were going to show you how to use the stadium method in the future lectures. And taping is the most common method for you to measure the distance. And it's easy, and you just need to bring the tape to the field. But there will be a lot of issues for you to do the correction about the result from the taping. And I will probably introduce how to do the correction in the next lecture. Also, we have the electronic distance measurement, ETD. The total station is one method, one type of the EDM tool. And the last one is a global position system, GPS. GPS is very simple, but the device is quite expensive. So that will be the basic method we're going to use. And in the lectures, we will focus on the taping method. For taping, the procedure is quite simple. Basically, you will just apply a no length of the graduated tape. So you have the marks on the tape to tell you how long it is from the start point to the point you observe, and directly apply the tape to the line of a number of times if you are not quite sure about how your observations. You need to repeat the measurement for multiple times. And usually we just use the tape to measure distance between two existing points. And also we can find out the a point based on a starting point and a no distance. So this is the general application about taping. And there will be several types of the tapes. The first one, which is the quite old one, is Gormans Chain. The chain is about 66 feet long, and it's divided into 100 links, and each link will have the length of 7.92 inches. And this is quite an old taping tool. It's developed by Edmund Gunter in 1600. And so this one is usually measured with the number of the chains and the number of the links. So one chain will be equal to 4, also divided into 4 rows, and 80 chain will represent 1 mile. So that's the how you can convert the length of the chain and links to the international unit. And we also have the engineer's chain. This is quite similar to Gunter's chain, but in this kind of chain, each link is about 1 feet long, and is usually used for the engineering project. And another one is the surveyors and the engineers tape. This is the most common tape that we are using. The one that is actually applied in your field experiment. Usually have the width of 1/4 or 3/8 inches, and the length could be 100 feet, 200 feet, and 300 feet, or 100 meters, or it could be shorter, like 10 meters, 5 meters. And there will be multiple types of making and graduations, and also these kind of scales could be available in chains, in feet, or in meters. And as they have the smaller scales, the scales is graduated. So you can actually, if it's marked in feet, you can read the feet, and also the inches and tenths of the inches and so on. And usually, if the tape is the length of the tape, if it's set as 100 feet, you will have an actual feet for you to mark the distance, additional smaller distance along the line. So you will have some buffering length for you to conduct the experiment. And another type of the tape is the invert tape. It's made of the special nickel steels. This one is designed to reduce the impact of the temperatures. And we know that when the temperature is high, for basically most of the materials will expand a little bit, and this will affect the accuracy of the distance measurement. And this kind of nickel steels will reduce the impact of the temperature. And this kind of tape is extremely brittle and expensive. So usually we do not have this kind of tape in our lab. And at most of the time is applied as the way to verify whether the other type of the tape, the marks in those tapes are accurate or not. So it's just is used for the calibration. And the common type of the tape would be the made of the cloth, the fiberglass or PVC, and the figure shows this type of the tape. And I believe some of you have used this tape in the experiment this week. So the accuracy would be a little bit lower compared to the invert tapes, and but it's very easy to store, and it's convenient for you to use. Usually can measure to the accuracy of 0.1 inches or to the 1 millimeter. And so those would be the general types of the tapes you can use. Also, we have there will be some accessories you have to use to do the taping experiment, but not all of them will be necessary for the experiment. The first one would be the taping pin. It's usually have the set of the 11, and you could just place the taping pin at the some locations where along the line and where you want to do the measurement. This is usually applied to mark the tape length, like you can set at every 10 meters. You also have the hand level to determine the required plumbing height. This one is this is especially useful for you to measure the sloping ground, or to when you need to measure the horizontal distance on the ground with certain slope. And we have the plumb bob, which is also used for you to measure the ground with different elevations. And the tension handle is very important for you to do the correction. You can measure the tension applied for the tape. And this is we're gonna learn how to correct the impact from the tension applied to the tape. And you have the pocket thermometer to measure the temperature, and the range poles to mark the ground for the long distance. If you want to measure a very large area, you need to have the range pole to control the direction. Make sure that you not you are stay on the straight line. And this would be the pictures to show you these kind of accessories: the taping pin, plumb bob, the tension handle, range pole, and the pocket thermometer. Of course, we did not use all of them in the lab experiment. So in your data analysis, try to make some consideration about it. Make sure that you know they have some impact to your measurement result. And the next thing we're going to learn is about the measurement of the distance measurement under the level ground, which is the simplest scenario. So if you want to measure the straight line on the smooth level ground, what you need to do is you just need to apply the tape along the line, and usually we just measure the shortest distance between the 2 points. So you apply the one end of the tape to the start of the line, and just stretch the tape till the end of the line, and then do the reading there. Of course, also you need to you apply the tension there. There will be you need to have the tension handle to measure what the tension is actually applied to that measurement. And you also need to have the plumbing. If the road is slightly uneven, the ground is slightly uneven, and this is the way for you to make sure that you are actually measuring the horizontal distance. And you also need to mark the tape length to where's the part you want to read the scale from the tape, and then you need to conduct the reading. Make sure that you have read to the minimum scale in the tape, and also you have some uncertainty or the precision included in your final recording. And after that, you need to record that one in your field notebook, and record all the values. And if necessary, you should make a multiple measurement, and make sure that all these measurements are consistent. So this is about the smooth, the flat area. But if the road is not smooth, and you will observe some slope, then the measurement will be a little bit different. In that sense, we need to use the breaking tape method to conduct the measurement on the sloping ground. So here's the procedure for you to do the breaking tape method. So first of all, you need to hold the tape horizontally and using the pump at one or at both ends. And then you have to measure the shortest distance once at a time between these two locations. And and you try your best to hold the tape horizontally. And I know this is very hard for you to control, but that's also the reason we observe some errors in the breaking tape method. It's acceptable, but it's one kind of way for us to measure the horizontal distance between of the sloping ground. And then you will move to the next segment. Like you can start from point A to point B with 5 meters, and then move to the next one from B to C, 10 meters, and then from C to D for another 15 meters. That's the way for you to get the horizontal distance from A to D, which is totally around 30 meters. So that's the breaking tape method, and you will have some experience about doing the breaking tape method in the field, but I'm quite sure there will be some error. So you need to go back to check how you're gonna explain these errors in your measurement. And the other way for you to measure the horizontal distance is called the slope taping. So in this method, instead of measuring the horizontal distance directly, we just measure the distance of the on the surface of the slope ground. So to do the sloping taping, there are some requirements. First, we need to make sure that the ground is fairly smooth. Usually, if it's some of the man-made slope, that will be easy. But if it's some nature area, you need to find some place that is smooth enough, or you have to make sure that your tape is smooth. It's a line as it's a place applied in the straight line. Or it could be applied to the slope that is very steep. If it's very steep, it's also fine for us to apply the slope taping. And in this method, we will just measure the slope distance directly, and then we will record the vertical angle or the zenith angle, and we're going to use these two values, the angle and the slope distance, to calculate the horizontal and the vertical distance. So, for example, let's consider a slope from point A to point B. It has a certain grade. And we want to measure the horizontal distance from A to B. So this would be the, you will see that the horizontal distance will be from A to B prime. And this would be in the right angle, 90 degree. So in the slope taping, we actually measure distance of the slope, say it's S. And we will then measure the vertical angle, say theta, or we can measure the zenith angle, say Z. With that, does anyone know what's the horizontal distance for the from A to B? Okay.
Cosine theta.
So yes, so we have the say that this is the horizontal distance h, and so we have h equal to s times the cosine theta. So remember here theta is the vertical angle, and it can also be represented as the slope distance and zenith angle. So if you have the zenith angle here, which means that the zenith angle is also applied at the angle AB to B prime. So we have the value of the horizontal distance as S times sine zenith angle. And I saw there are some questions about the zenith angle. So zenith angle is actually represent the angle between the line, say that the A to B, to the vertical line. And the vertical line is the line which is perpendicular to the point where you are standing. So this is a vertical line. You can actually go back to check the node 2 for the definition of the vertical line and zenith angle. So this is the way for you to find out the horizontal distance between A and B. And similarly, you can find out the vertical distance between A and B. Say that this is a letter H. No, let's just say that this is V. So we have V equal to, in this sense, that we have V equal to S times, that will be S times sine theta, and it will also be S times cosine zenith angle. So that's the way for you to get the horizontal and the vertical distance based on the slope. And now let's see one example. Assuming that we have the slope measurement of 29.952 meters, and it's measured between 2 points. The vertical angle is 4 degrees 30 seconds. What's the horizontal distance? Do you have any ideas about how to calculate the horizontal distance? So at first, I will probably just draw the figure and the figure to show this specific problem. So we have point A to point B, and S equal to 29.954 meters, and we have theta equal to 4 degree 30 minutes. We want to find out the value of horizontal distance. So do you think how we're gonna get this result? Have any idea about it?
Would we first have to convert it from minutes to like 4.5 degrees?
Yes. So the we need to know how to convert the this angle to the radian. It depends on what kind of calculator you are using. Some calculator can get the can calculate the sine and cosine through the degree and the minutes directly. Some of them need to get the radian value of in order for the angle in order for you to calculate the value of sine and cosine. So let's say we have the slope and the vertical angle. So we have the horizontal distance as equal to the slope times cosine theta. And the slope is 29.954. And the vertical angle is 4 degree 30 minutes. And you may have some questions about how to convert the angle from the degree minutes to radian. So so let's just give you a quick method for you to convert the value. So the just take this one as one example. We have the value as 4 degree 30 minutes, and we want to go to the radian. So what you need to do is like you need to use the angle theta times, for any angle, theta times pi divided by 180 degree. So here pi is the pi equal to 3.1415 and other values. So this is the constant. In this case, in this example, we have theta equal to 4 degrees 30 minutes. So we have first need to convert this this angle to degrees. So for theta equal to 4 degrees 30 minutes, that will be 4 degree plus 30 minutes divided by 60 minutes. So each 30 minutes represent, each degree will represent the 30 minutes. So this one just tell you how much degree it is for the 30 minutes. So with this case, you will definitely get the result as 4.5 minutes. So what we get is like for H equal to 29.954 times cosine. The theta, the angle of theta is 4.9 degrees. So convert this one to radian, is a 4.5 degree times pi divided by 180 degree. So this will give you the result as, let me just quickly check that one. The result would be 29.862 meters. So that's the way for you to find out the horizontal distance with the slope measurement. So this is the first example. And I'll give you some time to work on the second example, considering we also have another, we want to set a point D, which has a horizontal distance of 195 meters from the point E along a line having a slope of 5 degrees and 30 minutes. We will then want to find out what's the slope distance for this from point D to point E. So for this one, for this problem, let me just first draw the also draw a line of graph to represent the problem. So we want to set up the point D, and it will be actually set up the D from point E. So we have E here and D here, and we know the horizontal distance from D to E, which is the horizontal distance we want to set, is 195.00 feet, and the vertical distance, the vertical angle is 5 degrees 30 minutes. We want to find out the slope distance from D to E. So I'll give you some time to work on that before we finish this class. Can anyone give me the answer about this question?
Um, 195.902 meter.
Yes. So I'll just go straight to the solution. The answer is correct. Of course, the slope length should be higher than the horizontal distance. So we still need to call the formulas we defined in the previous slides. We have h equal to the slope distance, the horizontal distance equal to s times cosine theta, and this one indicates that s equal to h divided by cosine theta. H is 195, and theta is 5 degrees 30 minutes. So we can still do the conversion. Theta is 5 degrees 30 minutes. So we have 5 degree plus 30 minutes divided by 60 minutes. That is 5.5 degree. So with that, you can convert this one to gradient. 195 divided by cosine 5.5 times pi divided by 180. So with that, the slope distance is 195.50 feet. So this is the way for you to play with the horizontal distance and the slope distance. Of course, we have another example about the vertical distance. I will give you the introduction in the next lecture. And also, you should remember that if there's any if it depends, this kind of conversion from the angle to radian, it actually depends on the mode of the calculator that you are using. If your calculator is advanced, you can just type the angle with degree and minutes directly. If it's not, like if you are using Excel, you have to pay attention about the values. You need to convert the angle to the radian. Okay, so that will be all about the lecture today. Do you have any questions? Okay, if you don't have any question, then that will be all about the lecture today. And I would really appreciate your time in this class. And also keep your mind about the deadlines in the homework and the lab report. Send me email if you have any questions about this class and the task assigned to you. Good. Okay. Thank you very much for your time. And that will be all about the lecture. And I will see you tomorrow.